Hello everybody, so we're going to continue with 8.2. 8.2, we didn't finish it last time, but we introduced polar coordinates, and today we're going to go over graphs. We're going to sketch the graph of polar equations. So let's go ahead and do that. Sketch, let me give you an example. Sketch r equals 3 minus 2 cosine theta. If you want to, take the time, maybe don't write anything for now, and just watch me graph, sketch this, okay? So let's do this. You have theta and you have r, so you want to choose values of theta and find out what the corresponding r value, okay? So let's start with theta 0. When theta is 0, cosine 0 is 1, right? So 1 times 2 is 2. So 3 minus 2, it would be 1. Okay? Now when theta is, let's just say pi over 3. We can go pi over 6 if you want as well. But let me go ahead and select pi over 3. What is cosine pi over 3? So what would r be? So I can write it down if you like here. R would be 3 minus 2 cosine pi over 3. Now cosine pi over 3 is like sine pi over 6. So 3 minus 2, 1/2. So 3 minus 1, that's a 2. So when theta is pi over 3, r is 2. Okay? Now you can select any value. So what I'm going to do here is I'm going to select 0, pi over 3, pi over 2, 2 pi over 3. You can also select pi over 6 as well. So let's see. When theta is pi over 2, what do you get? Let me write it down here. R would be equal to 3 minus 2 cosine pi over 2. We know that cosine pi over 2 is 0. Okay, so this is 0, this goes away, so r would be what? 3. That's what's left, 3. Okay, so let's go ahead and select 2 pi over 3. So take a look at what I'm choosing here. Here's our pole right here. This is 0. So I'm choosing, this is pi over 2. This is pi. I'm choosing like pi over 3 here, and this is 2 pi over 3. You could have chosen also pi over 6. It's up to you, right? And this is 3 pi over 2. We need to know how the graph look like, right? So this is pi over 3. So this one would be pi over 3, and here is pi over 2. So let me select 2 pi over 3 as well. So let's 2 pi over 3, just to make things a little bit easier since I already selected pi over 3. So pi over 3 would be the reference angle. So 2 pi over 3 is in quadrant 2. Quadrant 2 is, the cosine is negative. So it'd be similar to that, but what? So you have 3 minus 2 cosine 2 pi over 3. That's the same as 3 minus 2 times negative cosine pi over 3, right? So it would be 3 plus 2 times cosine pi over 3, which is 1/2. So then that gives me what? 4. So 2 pi over 3, r is 4. Okay, so let's see, we can select pi, right? And let's see what you have here. Select pi. When theta is pi, what's cosine pi? Cosine pi is -1. If you want, I'll write it down again. 3 minus 2 cosine pi. Cosine pi is -1. So that's 3 plus 2, isn't it? So that would be 5. So when theta is pi, r is 5. You notice it's growing, isn't it? Maybe I should have picked also pi over 6. But cosine pi over 6, I can see it. It's root 3 over 2 is going to be a decimal, which is okay. Let's see. What do we have here? We can select other points as well. What do we have? So we selected 2 pi over 3. This is pi. We can select 4 pi over 3 as well. And 4 pi over 3 is gonna get the same value as pi over 3, wouldn't it? Well, I mean 2 pi over 3. You know why? Because the reference angle is pi over 3, right? And the cosine in these two quadrants is negative. So 4 pi over 3 is going to have the same value of r as 2 pi over 3, which is 4. You may, if you want to, go ahead, plug it in. This would be 4 pi over 3. This one would be negative cosine pi over 3. Again, in quadrant 2 and 3, the cosine is negative. Okay? All right, so let's select 3 pi over 2. That's easy to select because cosine 3 pi over 2 is 0, just like cosine pi over 2. So this is 0. 0 times 2 is 0. So r would be 3. Okay, so let's go ahead and choose, now, let's choose 5 pi over 3. 5 pi over 3 is what? 5 pi over 3 is going to have the same value as pi over 3, right? Because let me go ahead and write it down here. R is 3 minus 2 cosine 5 pi over 3. And 5 pi over 3 is in quadrant 4. It's positive. It's the same as cosine pi over 3, right? So it's going to be the same value. So this is 2. So 5 pi over 3, what do you get? You get r is 2. And let's do one more, 2 pi. And then 2 pi will come back here. Cosine, what is cosine 2 pi? So r is 3 minus 2 cosine 2 pi. Right? So what would that give me? Cosine 2 pi is the same as cosine 0, so 3 minus 2 times 1. Cosine 0 is 1. 3 minus 2, that's 1. So here is 1. So how do we graph it? Let's go ahead and create the radius. Remember, it's going to be a little bit tough as we're going to go all the way to 5. So I'm going to try, take my time. So 1, 2, 3, 4, the largest is 5 here, so I'm going to use that. Okay, so let's try to graph it. When theta is 0, r is 1. So this is theta 0, r is 1. Okay, when theta is pi over 3, r is 2. Should be here. R is 2. This is r2. Radius 2. So it's going to go this way. Okay, but before we find out, let's go ahead and get the other values. When before we start graphing, pi over 2 is 3. So this is pi over 2. R is 3, 1, 2, 3. 2 pi over 3. Here's 2 pi over 3. R is 4, so 1, 2, 3, 4. Okay. And when theta is pi, r is 5, so 1, 2, 3, 4, 5. This really should be, there's a difference, it should be here. close enough. 4 pi over 3 is 4. Here's 4 pi over 3. 1, 2, 3, 4. When theta is 3 pi over 2, 3 pi over 2 is 3. So this is just in case. I hope you see them. 3 pi over 2 is 3. Here's 3 pi over 2 is 3. 1, 2, 3. So I'm just plotting in the values, okay? And when 5 pi over 3, it's r is 2. 5 pi over 3, r is 2, 1, 2. And when it's 2 pi, it comes back to 1. Okay? So let's go ahead and graph this. Well, so we're starting here. It's going to be a little bit tough graphing it. So here, here. So actually it has like this. Okay. So it has a little bit like this shape at 0. So it looks like this. Okay. This is the shape of it. We call this limacons. It's almost like a heart. Let me erase it for you. This is really gets me to get this right here. So let me do it slowly. Okay, that's more like it. Okay. So this is a graph of r equal 3 minus 2 cosine theta. Again, you pick values of theta and you find out what r is, really as simple as that. You could have chosen, we didn't choose pi over 6, but if you wanted to, we could have. What is pi over 6? Let me do it one for 1 pi over 6. R would be what? Let me write it down here. R would be 3 minus 2 cosine pi over 6. So 3 minus 2 cosine pi over 6 is root 3 over 2. So this is 3 minus square root of 3. So if you go ahead and get your calculator, and what is that going to give you? Going to be close to 127, 1.27. So pi over 6 is here, right? And here's a graph of 1. And sure enough, this is 1.27 is between r equal 1 and r equal 2, closer to 1. Sure enough, this is it. Do you see that? So it's close enough to what? To r equal 1. So you could have chosen other values as well. So I made the choice to select pi over 3, 2 pi over 3, because I found it easier. Cosine pi over 3 is 1/2. So it will give you half the number, but you could have chosen pi over 6. The tough part for me is actually to graph it, especially when you have limacons. Limacons, the formulas for limacons look like this. R equal a plus or minus b cosine theta. R equal a plus or minus b sine theta. Okay. A and b are both greater than 0, and a over b is between 1 and 2. You don't have to remember those. I just wanted to show you what it is. So this is the graph of limacons. This is the way we graph sketch polar equations. This is the way you do it. Okay, so let's have another example. By the way, this is also called a limacon. If you have, it has an inner loop. This one doesn't have an inner loop, just to let you know. Okay, so we graphed one example. We can graph another. We can graph so let's go ahead and graph or sketch the graph of r equal 4 sine 2 theta. So let's go ahead and graph this. So you have theta and r. When theta 0, sine 0, 0, and here you have 0. If I select pi over 4, sine, it becomes sine 2 pi over 4. So r 4 sine 2 pi over 4. So this cancels with this, and you have pi over 2. What's sine pi over 2? That's 1. So 4 times 1 is 4. Let's select pi over 2. When theta is pi over 2, what does that give you? R equal to 4 sine 2 times pi over 2. The 2 and the 2 cancels. 4 sine pi is 0. So 4, 0. Okay? And let's select pi over, or 3 pi over 4. So what is 3 pi over 4? When r is, when theta is 3 pi over 4, you have 4 sine 2 times 3 pi over 4. So this divided by 2, this divided by 2 is 2. So you have 4 sine 3 pi over 2. So what's sine 3 pi over 2? It is a negative 1. So 4 times negative 1 is negative 4. So when theta is 3 pi over 4, is negative 4. When theta is pi, take a look, it becomes sine 2 pi. Sine 2 pi is 0. 0 times 4 is 0. You notice they go between 0. Every other angle here is 0. Let's see 5 pi over 4. 5 pi over 4, that is r equal 4 sine 2 times 5 pi over 4. So this divided by 2, this divided by 2 is 2. So 4 sine 5 pi over 2. If you notice 5 pi over 2, so pi over 2, 3 pi over 2, 5 pi over 2, same as pi over 2. Same as pi over 2. So that's 1. So this gives me 4. So 5 pi over 4 is 4. If we select 3 pi over 2, so the 2 is going to cancel. You'll be left with what? R equal 4 sine 2, 3 pi over 2. The 2 into the 2 cancel. Sine 3 pi is 0. 0 times 4 is 0. So they're alternating, aren't they? Let's do a couple of more. 7 pi over 4. 7 pi over 4 is going to be similar to what? 3 pi over 4, isn't it? 7 pi over 4, you'd be left with 7 pi over 2, wouldn't it? The 2 and the 4 cancel out. See, they are canceling out. 2 and the 4 cancel out with 7 pi over 2. Where's 7 pi over 2? So 5 pi over 2 is 7 pi over 2. So that's going to be negative 1. Negative times 4, negative 4. You can plug it in if you like. In there, it should be negative 4. Now if we select 2 pi, that's easy to see. 2 times 2 pi is 4 pi. Sine 4 pi is like going 2 full circles, right? 1, 2 pi, 2 pi, so that's 0. So let's go ahead and graph this. Here's your pole. So we're going to have force, right? So this is pi over 2, 3 pi over 2. And try to make it as even as possible. We took multiples of pi over 4. So let's go ahead and do that. So this is pi over 4. and here pi over 2, and here 3 pi over 4. Here is pi, here 5 pi over 4, 3 pi over 2, 7 pi over 4, and comes back here to 0. So let's go ahead and sketch it. Watch me here. So theta 0, r is 0. So I'm starting here. When theta is 0, this is 0, r is 0. When theta is pi over 4, r is 4. So this is r4. So I'm going from here to here. Everybody with me? This is pi over 4. When theta is pi, 4, r is 4. So 1, 2, 3, 4. When theta is pi over 2 is 0. So I'm going to pi over 2. This is pi over 2. How do I go to pi over 2? And where is 0? Here it is. So I'm going to pi over 2. Here it is. Do you see that? This is pi over 2 and I'm at 0. Now let's go to 3 pi over 4, negative 4. This is 3 pi over 4. But if you recall last time, when r is negative, you go opposite. So this is 3 pi over 4, but r is negative, so I go in this direction. You with me? So here, I go 3 pi over 4, negative 4, so I go here. Again, r is negative. Now, I need to go to pi, and it's 0. Where is pi? Here's pi, and here's the 0 for pi. So I go in to pi, here it is. Okay, from pi, I go to 5 pi over 4. Where's 5 pi over 4? There it is. 5 pi over 4 is 4. So I go 1, 2, 3, 4. Here it is. Now from 5 pi over 4, I go to 3 pi over 2. 3 pi over 2 is 0. Here's 3 pi over 2, and here's the 0 for 3 pi over 2. And here it is. Then I go to 7 pi over 4. 7 pi over 4 is negative 4. Here's 7. Oh, I'm sorry. This is pi over 4. Here's 7 pi over 4, but it's negative. So I have to go in opposite direction. This is 7 pi over 4, but since it's negative, I go in the opposite direction. So here is 4. Then from there, I go to 2 pi, 2 pi is 0. Whereas 2 pi, I come back here, and there it is. What does it look like? A rose, doesn't it? This is called the rose curve. This is a rose curve. Rose curves are given by, you don't need to memorize them, it's good though to know them, are given by r equals a cosine and theta. A cosine and theta, and r a sine and theta. A cosine and theta, a sine and theta. Now, if n is even, like we have in here, if n is even, the curves have 2 n petals. The curve has 2 times n petals. What are the petals? There they are. 1 petal, 2, 3, 4. If n is odd, the curve has n petals. So remember, take a look in our example here. R is 4 sine 2 theta. This is n. Since n is even, you have 2 n petals. 2n, that's 2 times 2, and 4 petals. Sure enough, here are the 4 petals. 1, 2, 3, 4. If that had been n as odd, if that had been 3, I would have n petals, which is 3 petals. So this is the way, this is the rose curve. Okay? So we are graphing polar equations. These are polar graphs. Okay? All right. Now let's go ahead and sketch the graph of this polar equation r equal 3 sine theta. So how do we graph it? Same as we've done. So here theta, let me see. When theta is 0, sine 0 is 0, so this is 0. Okay, what else should we pick? We can select sine pi over 6, pi over 6. Sine pi over 6 is 1/2, so r would be 3 sine pi over 6, so 3 times 1/2. So 3 over 2, this is 1.5. So this is 1.5. Okay, so we can also select pi over 2. Sine pi over 2 isn't at 1, right? 3 times 1, wouldn't that be 3? Okay. And if you recall the graph here, unit circle, this is sine pi over 2, this is 0, 1. This is a cosine, this is sine, so sine pi over 2 is 1. Now, pi over 2, what else should we select? We can select 5 pi over 6 as well. As you can see here, 5 pi over 6, the sign is in second quadrant, is also positive. It's going to have the same value. Sine 5 pi over 6 is the same as sine pi over 6. So this is going to give me 1.5, right? And let's go ahead and select as well pi. Sine pi is 0, and you have what sine pi is 0, so you have here 0. So let's go ahead and graph it. Let's go ahead plot here. So this is pi over 6, this is 5 pi over 6, this is pi, it's pi over 2. So we have, this is 1, 2, it's still tough for me to graph it. There you go. When you have 0, theta 0, r 0, theta is pi over 6, here's pi over 6, here is pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6. So when theta 0, r 0, pi over 6, here's pi, it's 1.5, this is 1, this is 2, right in the middle, 1.5. When theta is pi over 2, r is 3, so what do you have? It's going in this direction and this direction, right? 5 pi over 6 is 1.5, between 1 and 5 here, so this you go. And then here pi is 0, this is pi 0, there it is. This is a circle, isn't it? This is a circle. Yeah, isn't it? So this is a graph of r equal 3 sine theta. So this is a circle. If you remember, we did this last time. How do we write it in Cartesian as a Cartesian equation? So if you recall, x equal r cosine theta and y equal r sine theta, and x squared plus y squared equal to r squared. All right? And tan theta was y over x. So if I here multiply by r on both sides, what am I going to have? So this is multiplied by r, and this is multiplied by r. So that gives me r squared equal r times 3, or 3r sine theta. Well, r squared is what? X squared plus y squared equal 3r sine theta is y. This is a circle. When you have both x and y are square with the coefficient is the same, you have a circle. Centered is not 0. Here's a center. You can, if you want to, subtract 3y, write it on this side, and here y square, and complete the square to find the center, right? So b is -3/2. You have to add 1/2. You have to add b squared, so this is 9/4, 9/4. So this is the same as x minus 3/2 square plus y square equal to 9/4. This is centered, this circle, center at 3/2, 0, with radius 3/2. So there it is. This is the center. Radius is 3/2. R is 3/2, or 1.5. There it is. 1.5 R, up and down. So this is a circle with radius. If you notice, I stopped at pi because I noticed this is going from 0, 1.5, 3, 1.5, and come back to 0. I noticed like it's a circle. So that's why I stopped at pi here. Okay? What would have happened if you went out and select 7 pi over 6? What would have happened? Then you have r equal 3 sine 7 pi over 6. 3 7 pi over 6. Sine 7 pi over 6 is, remember here the sign is negative, is negative sine pi over 6. So that's -3 sine pi over 6 is 1/2. So -3/2. So when it's -3/2 or -1.5, right? When it's 7.6, 7 pi over 6, r is -0.5, which means you have to go to the opposite direction and come back to that point. See what I mean? So 7 pi over 6, and then r is in opposite direction, so I go r 1.5. So I'll come back to this point. So that's why I stopped. I noticed that it's a full circle right here. Okay, but if you want, you can continue. You can continue with 3 pi over 2 as well. You're going to get the same same values here. So sine 3 pi over 2 is what? This is 0, -1. So it's -1 times 3 is -3. So 3 pi over 2, but it's negative. You go in opposite direction, comes back to this point. So these are, we just graphed few polar equations. And I'm going to stop here for now.